All right, Algebra 2, here we go. We've got dividing polynomials, Poly4. So it's a really nice way to transition from factoring polynomials to dividing polynomials. You can see how they're related, but also kind of how they're a little bit different. So with that, we need to make sure that we understand we've been using factoring to determine the roots of polynomial equations, both the real, if it touches the x-axis, and also the imaginary if it doesn't touch the x-axis. Let's take a look now. We're gonna look at dividing polynomials, see how it's related, but still different. I'm gonna start with the whole dividing by a monomial, one term, right? What we're gonna do is if you're dividing in the bottom, if your divisor, the bottom, has just a monomial, what you're gonna do is just treat it like fractions, right? Treat it like fractions. What do I mean by that? Well, I'm dividing everything by x cubed. Fractions, in order to add or subtract them, have to have common denominators. I'm just going the opposite way with the denominators. Instead of combining them to make one fraction, I'm splitting them apart to make two separate ones. And if I do that, I can look at my coefficients. Well, 32 divided by 8 is 4. And x to the 5th divided by x cubed is x squared. And how do I remember that? That's a really good question. X to the 5th, if you remember, is x times x times x times x times x. Divided by x cubed is x times x times x. So what simplifies? Well, x divided by x is 1. That's 1. That's 1. I'm just left with 1 times x, or 1 x squared, just x squared. Right? You can also think of it as subtraction. X to the 5th minus x to the 3rd, you've got x to the 5 minus 3 to get x squared. So how about the other one? Plus, well, 24 divided by 8 is 3, and x cubed divided by x cubed is 1. I've just left with 4x cubed plus 3. 32x to the 5th plus 24x cubed plus 8x, or divided by 8x cubed, results in 4x squared plus 3. Let's look at B. Okay, you're gonna try C, but let's look at B. I'm gonna split this up again. 36x to the 5th divided by 6x cubed plus 72x cubed divided by 6x cubed plus 48x squared divided by 6x cubed. So we just split it up into fractions again, all right? And now that we've done that, what we're gonna do now, same thing. 36 divided by 6 is 6. X to the 5th divided by x cubed, x squared. Plus 72 divided by 6 is 12. X cubed divided by x cubed, that's just 1, so that simplifies there. Now here's an interesting one. 48 divided by 6 is 8, but I've got more x's on bottom than top. I am going to just leave this as x, or 8 divided by x, because this is like x times x divided by x times x times x. I'm left with 1 on top and x on bottom. 1 times 8 is 8. Simplifies to this right here. So with that knowledge, you're going to try letter C. Give letter C a shot real quick. Come back, check your answers. All right, as you come back, you'll notice that if you do part C there, you end up with 3x cubed plus 5x squared plus 8 when you simplify. Okay. Now, what happens when we have to do division of polynomials by, well, in this case, we'll do binomials. What I'm going to do is take you back a long ways to the days of long division. Oh, I can hear the groans now. We're going to do long division here, all right? So what we're looking for, we say this is 698 divided by 32. So we start like this. Does 32 go into 6? No, it does not. Does 32 go into 69? It does, and most it goes in evenly 2 times. So I'm going to put the 2 here. 2 times 32 is 64. I'm going to put this in parentheses, and I'm going to subtract it. Well, 69 minus 64 is 5. I'm going to drop the 8. So again, now we're working in the tens here. Now, 32 goes into 58 one time. It doesn't go in twice evenly. That'd be too many times. So it goes in 1 time. I'm going to subtract 1 times 32, or 32 here. I'm left with 26. We call that 26 that we're left with our remainder. R26. Another way to think about this would be, this is like 21 and 26 out of 32. Our remainder divided by our divisor. We're going to do something similar in long division with polynomials. I've got x squared plus 8x minus 5 divided by x minus 3. Okay, take this nice and slow here. I'm going to have x minus 3 out here. Inside, I've got x squared plus 8x minus 5. We're going to start like this. We're going to only focus on the biggest term, the term with the biggest exponent, right? We've got x squared as that term. What I'm going to do is look at x squared and x out front, my two front first terms, because I have to write these in standard form, biggest to smallest exponents. What times x gives us x squared? Well, Mr. Brayman, that's x. Using our same thing in long division, x times x, this is, I'm going to subtract here again. I'm taking away x squared because x times x is x squared. I also have to multiply this by the -3. So this is x squared minus 3x. Minus 3x. So x squared minus x squared is 0. X minus -3x is plus 11x. I'm going to drop down the -5 just like I would do normally. And now I'm going to work like this. What times, in this case, what times x would, how can I get to 11x? Or how many times x go into 11x? Well, it goes 11 times. So here I'm going to subtract again. What am I going to be subtracting? Well, 11 times x is 11x. And 11 times -3 is -33. Do our subtraction again. And 11x minus 11x is 0. -5 minus negative, which is plus a positive, 33 becomes 28. Now, x does not go into 28. So right now you're done. Your remainder is 28. So right now you're looking at this as x plus 11 with a remainder of 28. But just like I did over here, I'm going to say this is actually x plus 11 plus my remainder, which is 28, divided by my divisor, which was x minus 3. There's a lot going on there. Totally get it. Totally get it. There is a lot going on there. We're going to step by step our way through another one. Okay, we're going to step by step our way through this one over here, which is a little more complicated, but not bad. We've got 15x squared plus 8x minus 12 divided by 3x plus 1. Do the same setup. 3x plus 1 goes out here. Inside, I've got 15x squared plus 8x minus 12. And I'm going to say the same thing. How many times, hey self, how many times does 3x go into 15x squared? Well, 3 times 5 would give us our 15, and x times x would give us our x squared. I'm going to now subtract from this. 5x times 3x, that's our 15x squared. 5x times positive 1 is plus 5x. I'll do my subtracting. 15x squared minus 15x squared is 0. 8x minus positive 5x, or 8x minus 5x, is plus 3x minus 12, because I'm dropping that 12 down, that -12. Then I say, self, how many times does 3x go into 3x? And that'd be 1. It goes in 1 time. So let's do our subtraction again. 1 times 3x is 3x. 1 times 1 is 1. And I'm going to subtract. Well, 3x minus 3x is 0. -12 minus 1 is -13. Because this has an x and this doesn't, I'm done. I can't go any further with this. So what I'm going to do, I'm going to say this is 5x plus 1 plus my remainder, which was -13, divided by my divisor, 3x plus 1. And that is how I get there. Long division. I know. It's a lot. There's a lot to work with. Okay. What I want you guys to do is to try this one. X squared minus 2x minus 35 divided by x minus 7. Now, some of you already might be going, oh, something should happen there because of factoring. And I'm saying, yeah. So what I want you to do, give it a shot, see what you come up with, and then we can talk about it. All right, so what makes this one interesting? Well, hopefully you see that you get a remainder of 0. There's no remainder. X squared minus 2x minus 35 divided by x minus 7 is just x plus 5 with no remainder. And for the eagle-eyed viewers out there, if you look at it, well, this could be factored, right? Negative 7 times positive 5 gives us negative 35. That adds to negative 2. Okay. So if I multiplied x minus 7 times x plus 5, I would get that. We're just doing kind of the same things. I know it's like, it's just weird to see it in this stage, but that's okay. That's okay. Something else that's interesting here, none of the others had this, but we had a remainder of 0. If you're doing division, you're dividing this binomial. Your divisor is a binomial, your top is a polynomial. If the remainder of 0 is 0, that binomial is a factor of the polynomial. It's a factor of the polynomial. So we're going to use that to our advantage. We're going to use that to our advantage. Now, what I want you guys to do now is to go ahead and try these two. Again, just go ahead and do long division. Ignore everything that says it might be a little easier down below. Try these two, once again, with long division, and then we're going to talk about it. If the remainder is 0, it's a factor. So do the division first. If the remainder is 0, it is a factor. If the remainder is not 0, it's not a factor. Okay, so try these out, see what you get, come on back, check your work. All right, mostly I want you to check your division first, then we'll talk about the answers kind of in the end here. You should have ended up with a remainder of -4 for the first part and 0 for the second one. Okay, if I go back to this first one, since the remainder is not 0, it's -4, that p plus 5 is not a factor of 2p squared plus 6p minus 24. Okay, but since in the second one, our remainder is 0, that makes p plus 7 a factor of 3p squared plus 29p plus 56. So you have to show me the work to see if it's a factor or not. It's just when you get down to that remainder. Now that remainder is going to hold a special place in our hierarchy here pretty soon too. But let's go ahead and take a look. I don't want to say easier. Maybe it is. It's a little less messy, I guess. I don't know. Let's take a look at this. Okay, I'm not saying it's easy, but it might be easier. What we've got is this thing called synthetic division. Synthetic. I mean, synthetic is kind of a word for fake, but it's not fake division. Okay, it's not fake at all. It's not fake at all. It just might look a little weird. So what I'm going to show you is this thing right here. What we're going to do, we've got this example here. We've got x cubed minus 2x squared minus 8x minus 35. We're going to divide that by x minus 5. We're going to take that x minus 5, solve for x, set it equal to 0 and solve. So my x value is 5. We're going to put this, I guess we're going to call this the house. So up here is the little house. Okay. I put this in my house. Now I'm going to take the coefficients of the polynomial that I'm dividing by. I have 1x cubed, negative 2x squared, minus 8x, minus 35. Again, this is very important that you put things in standard form, or else these coefficients won't make any sense and this won't work. Also, let's say we are missing one. Let's say this is like 1x cubed minus 8x minus 35. If there's missing one, you have to put a 0. Let's say x squared was missing. You have to put a 0 in for that as a placeholder. So write the known 0 in the house. We've done that. We're calling this little guy up here the house. Okay. List out the coefficients, which we have. We've got 1, -2, 8, -8, and -35 here. You're going to take that first coefficient, drop it straight down. So that 1 goes straight down. Now here's where things get fun. You're going to take that value in the house and multiply it by the number you drop down. In this case, it's 5 times 1. You're going to take that value and put it underneath here. So you've multiplied down, or multiplied the bottom value, and now you're going to add down. So -2 plus 5 is 3. Okay, we multiplied by the coefficient, we wrote the product underneath the second coefficient, and we added down. Now we need to repeat. This is going to go back to 4, right? So if once I did that, -2 plus 5 is 3. So I'm going to multiply the house number again. 5 times 3 is 15. I'm going to put that right here. I'm going to add down -8 plus 15 as a +7. 5 times 7 is 35. And when I add down, I get 0. So what happens is we've done the synthetic division. That's not all we have to do, though. We're trying to figure out what happens when I divide this. What does the value end up being? Right now, I've just got 1, 3, 7, and 0. Well, I need to write it in a specific way. Those coefficients, these are coefficients that mean something. Since the biggest exponent I had to start with was cubed, I'm going to knock it down 1 power because I'm dividing essentially x cubed by an x. My biggest value should be an x squared. This tells you how many x squareds I have. I have 1x squared. Then the next one tells you how many x's you have, plus 3x. Then the next one tells you how many just solo value or constants you have, plus 7. And then you get the remainder. In this case, it's 0, but if there was one, you could put the remainder over the divisor again. Now, this one right here, so that's the final polynomial. I'm not going to ask you to find the other zeros. We could, I'm not going to ask you to do that right now. What I am going to ask you to do is try this again here. I've got x squared minus 2x minus 35 divided by x minus 7. That problem looks really familiar. I think I've just done that one long division wise. Yeah, I did. Yeah, I did. I think right here, we ended up and we got x plus 5 when we finished it. I'm going to show you that it works the same way in synthetic division. Step 1, write the known value in the house. X minus 7 equals 0, x equals 7. Put this in the house right there. Take my coefficients of the polynomial. I have 1x squared, -2x, and -30. I'm going to move this over a little bit. 1x squared, -2x's, -35. I'm not missing any coefficients. I don't have to put any 0 placeholders. I'm going to give myself a little line. I like to make this extra thing. I call this the remainder box. This would have been right here had we put it over there. I like to call this my remainder box. I'm going to follow the steps. I'm going to drop the 1 straight down. I'm going to now multiply 7 times 1 and put it underneath the second coefficient. I'm now going to add down. -2 plus 7 is 5. 7 times 5 is 35. I'm going to put that right here and add down, and I get 0. Again, this is my remainder box right here, my remainder box. Just like we did a second ago, well, the biggest exponent is squared. I'm going to go 1 less than that. Well, 1 less than squared is just to the first power. This is how many x's I have. I have 1x. Now I'm back to my constants, plus 5. And then no remainder. That's what happens when I get that, when I divide there. Was that the same thing we got just a second ago, x plus 5? Yeah, sure was. Sure was. Okay. This only works when you have a binomial in this form right here with just x minus 7. okay, with just an x and a value. There are some funny things that happen if x has a coefficient other than 1, so I'm not going to really mess with that right now. Maybe that's a later time. So what we're looking for is just x plus or minus a number in here, not plus or minus like quadratics, but x and a constant. All right, the same thing still holds. Because this was 0, because my remainder was 0, I do have a factor. I do have a factor. Let's take a look at a couple things here. All right, it says divide the polynomials using synthetic division and determine if the binomial is a factor of the polynomial. That's a lot, but that's okay. It's just saying divide, and if that remainder is 0, it's a factor. That's all it's saying. But we got to use the math words, right? We got to make sure that we're all on the same page with the math words, the math speak, so to say. Let's look at this one here. I've got 2x cubed plus 3x squared plus 4x minus 5 divided by x minus 2. Get that house value. X minus 2, set it equal to 0, so x equals 2. That's my house value. I'm going to put that in the house. I'm going to look, my biggest exponent is cubed for my polynomial. So I need to have coefficients for a cubed, a squared, x to the first, and a constant. I need to have 4 coefficients. And I do. I have 2, 3, 4, and negative 5. Gonna set up my nice little remainder box here. I'm going to drop down my first coefficient. Then I'm going to do some multiplying. The house value is 2. 2 times 2 is 4. I'm going to add down. 3 plus 4 is 7. I'm going to multiply this value, that's 7, by the house number, which is 2. 2 plus 7, or I'm sorry, 2 times 7 is 14. If I add down, I get 28. Well, 2 times 28 is 56. And if I add down, I get 51. How do I write this out? Remember, our biggest exponent was cubed, so I'm going to go down 1. So my biggest one when I divide something is going to be x squared. In this case, I'll have 2x squared plus 7x plus 28 plus my remainder, which was 51, divided by my divisor, which was x minus 2. That's what I get when I divide. And because the remainder was not 0, x minus 2 is not a factor. Now you're going to do the next 3 of them here, but I want to point out something, the one that's just below. The one that's just below is missing an x squared. So when you go to set this up, 3 is in the house. Your coefficients are 2, negative 5. And since there's no x squareds, we got to put the placeholder of a 0 and then the negative 7 and negative 6. So with that said, that's your little bit of a hint on those next few. And then we'll come back and check and talk about it. All right, as you come back, you should notice a couple answers here. We did that first one together. If I look at the second one on the row, we end up with x cubed plus x squared plus 1 plus negative 8 divided by x plus 2. Since that remainder was not 0, that is not a factor. X plus 2 is not a factor. If I go down and look at the next one, I end up with 2x cubed plus x squared plus 3x plus 2. And because I had a remainder of 0, it was a factor. And the multiple choice one, I went through all of them, and the only one that had a 0 remainder was x plus 2 when x equals negative 2. Okay. Let's look one more thing. There's one more real cool part to look at this for synthetic division. It says use the synthetic division to evaluate 2x cubed plus 3x squared minus 4x minus 2 at x equals 3. In other words, what's the value of y? Because this is kind of like y equals, or in this case, f of x equals this function. What is the X value there? Well, rather than plugging it in, what you could do, you can actually do synthetic division, and your remainder is the Y value. Watch this, watch this, all right? If I do this, so X is 3, 3 is what goes in the house. I've got 2, 3, -4, and -2 as my coefficients. Get that remainder box ready. If I drop the 2 down, I've got 2. 3 times 2 is 6. I'm going to put that there. Add those two things together, I get 9. It's getting big, but it's supposed to. 3 times 9 is 27. -4 plus 27, that would be 23. If I multiply those two things together, -2 plus 69 gives me 67. My remainder in this is 67. If you plug 3 in, 4x to this right here, you will end up with 67. And I'll prove it. 3 cubed is 27, times 2 is 54. Plus, well, 3 squared is 9, times 3 is 27. Minus 4 times 3, which is 12. Minus 2, does that give us 67? Well, 54 plus 27, that's 81. 81 minus 12 is 81 minus 12. That is 69. Minus 2 is 67. That's just kind of a short way to find the Y value at that. You might see this and like, wow, that just seems so, what are they asking? That's all it's saying. Do the synthetic division, find out what the remainder is. Try the last one. Try the last one, see what you come up with. Hopefully it took a quick second. If you end up doing that, you go all the way through, you'll find out the remainder is -9. So if I plugged in -2 for this function, my Y value, my f of x, my value of the function when x is -2, the f of -2 is -9. And I promise you, if you graph that on Desmos or wherever you want to look at, that's what you'd come up with. With that said, that's kind of the end of dividing polynomials for now. We're going to kind of treat this the best we can, work hard, ask questions. Let's see what you guys can do. Take care. Have a great day.